This is part 2 of a review of arc length, sector area, and volume. In this video, we will focus on finding the volume of solids like pyramids, cylinders, prisms, and cones. Alright, we're supposed to find the volume for each of the following solids. For number 6, we are dealing with a pyramid. The formula for the volume of a pyramid is 1/3 the area of the base times the height. Alright, so that's what we need to do. So we need to do 1/3 times the area of the base times the height. Now we know the height is given to us directly. It's 14. Okay? So all we need is to calculate the area of the base. Now the base of this pyramid is a triangle. It's this triangle at the bottom. Alright, so let me highlight that in green. This triangle is the base. So this is what we need to find the area of. Now I'm just going to rotate this and put the picture off to the side. It makes it easier to calculate the area if we set this up in a way that we're used to. Alright, all I've done is I've rotated this image around. So right now here's the right angle, okay? So of course you see the hypotenuse is 15, so that'll be like right here. Alright, this 9 would be right here, though it wouldn't really matter if you accidentally put it here, you'd still get the same answer. But anyway, this is what we don't know right here. Alright, so we need to find the area of this triangle, alright, because that's the base of the pyramid. So the area of this triangle, so we need to talk about that. Alright, I'm going to call it, let's see, I'm going to call this area capital B because it is the base. It's the area of the base of the entire pyramid. Alright, but the area of a triangle is 1/2 base times height. Now I'm using a lowercase b because it's just it's just a line segment. Alright, so I know the height of this triangle is 9, but I don't actually know the base of this triangle. Alright, it's not 15. So I shouldn't be doing 1/2 9 times 15 because 15 is neither the base nor the height. You know, if I left the triangle in the shape that it was in before, okay, I could have looked at it as the base of this triangle. But if I do it that way, the height would be like right here. And we just don't have it, and we would have no way of finding it. In this orientation, 9 is definitely not the height. It's all slanted, right? The height should be straight down. So either way, we're not just doing 1/2 9 times 15. That would be a mistake. What you need to do is, you know, we gave you a right triangle for a reason, so that you could orient it so that one of the sides is the base or the height. And we can do the Pythagorean theorem to find the other side of the triangle. So that's what you need to do. Pythagorean theorem, that's the key. So I'll do that off to the side right here. So basically x squared plus 9 squared should equal 15 squared. So that's x squared plus 81 is equal to 225. Subtract the 81 from both sides. Okay, that's 144. Alright, take the square root of both sides. Whoops. And we're getting 12. Alright, so that means this side of the triangle is 12. And that is the base of this right triangle. So back to finding the area of the triangle, Alright, that is 1/2 base times height. 1/2 12 times 9. Okay, half of 12 is 6. Alright, so I'll just show the step. So, whoops, I don't need the 1/2 anymore. So I'm doing 1/2 of 12. Alright, 1/2 of 12 is 6. And then 6 times 9 is 54. Okay, so that is the area of this triangle. That is the area of the base of this pyramid, is 54 units. Alright, so now we can go ahead and calculate the volume of the pyramid. So it's 1/3 times 54 times, what was it? 14. So that's 252. They didn't give us any units, so I'll just say 252 cubic units, whatever they may be. Okay, so that is it for problem number 6. Alright, for problem number 7, we are supposed to calculate the volume of this cylinder. So the volume of a cylinder is area of the base times the height. So we're supposed to calculate the area of the base and multiply that by the height. Now the height of a cylinder is going to be the distance between the two bases, and we're told that that is 7.8. So we know that the height, even though it's sort of sideways, it still counts. So the height is the 7.8. Okay, so now we need to calculate the area of the base. Well, the area of the base is a circle. Okay, so I mean, this is the base right here. Okay, that's my base. Okay, so that's a circle. So I'm going to go ahead and find the area of that circle. I know it is given by the formula pi r squared. Okay, but what we have here is the diameter. Alright, 5.2 is the whole way across. So the radius should be half that. Alright, so 5.2, I said 5.2 divided by 2. Okay, that's 2.6. Okay, so the radius is 2.6. So this should be pi 2.6 squared. Alright, so let's just square the 2.6. Okay, so 2.6 squared, that's 6.76. So that's 6.76 pi, alright, is the area of the base. So back to this. So we're supposed to be doing area of the base times the height. So that's 6.76 pi times the height. .8. Alright, and I get 165.65. Got to round up. Alright, this time they gave us units that were yards, so this will be cubic units. Alright, so that's it for number 7. Alright, now this is a prism, and we need to find the volume of the prism, but we need to know that the formula for the volume of a prism is area of the base times the height. Okay, so there will be no 1/3 or 1/2 or anything like that. Okay, we need to calculate the area of the base and then multiply that by the height. Now, one of the trickiest things is just to understand what part of the picture we're talking about. Take the height, for example. They gave us the height of this prism. So, which one of these 3 numbers do you think is the height of the prism? Okay, the height of the prism is 6. Alright, a lot of people probably were thinking 2 is the height of the prism, because 2 is the height of this triangle. Alright, but when you look at a prism is 2 polygons that have all the vertices connected. Alright, they're 2 bases that are connected by these straight lines. In this case, the 2 bases are this triangle in the front and this triangle in the back. So these 2 triangles are the bases of this prism. And the height of a prism, even if it's lying sideways, the height is always the distance between the 2 bases. Okay, so that distance is 6. Now I need to calculate the area of the base of the prism. Alright, the area of the base of the prism is the triangle, like I said. So for example, this yellow triangle is one of the bases of the prism. So I need to find the area of that. So let's do that. So this is a triangle. Now the area of a triangle is 1/2 base times height. I'm using a lowercase b now because this base is just a segment. Luckily they gave us both of these things. So it's 1/2 and 10 is the base and 2 is the height. So 1/2 10 times 2. So that means the area of this triangle, 1/2 of 10 is 5. Alright, so that's 5 times 2. So that means the area of the base is 10. Okay, so back to volume. The volume of this prism is going to be 10 times 6, which is 60. Alright, cubic units. Alright, so that is it for number 8. Alright, number 9 is a cone. And the formula for the volume of a cone is 1/3 the area of the base times the height. So I will be doing 1/3, and I will need to find the area of the base, and I will need to multiply that by the height. Now the height they gave us directly. The height is 3 kilometers. It's a very large cone. Alright, maybe this is a tornado or something. Anyway, now we need to calculate the area of the base. Now the base of the cone is this circle. Now they gave us the diameter of the circle here, which is 2 kilometers, but we're going to need the radius, and the radius is going to be 1 kilometer. Okay, so that should be fun, using a radius of 1. Kind of rhymed, so because I'm awesome. So calculating the area of this little circle here, we know that the area of a circle is pi times the radius squared. Okay, so the area of this should be pi times 1 squared. Okay, so that is just going to be pi, alright, because 1 squared is just 1. So the area of the base is simply pi. Okay, so this will be pi. Now, I can already see that the 1/3 and the 3, they're going to cancel each other out. 1/3 of 3 is 1. So the answer is going to be pi. I'm curious what would happen if I type this in my calculator. All right, 1/3, and what if I did pi and then times 3? Yeah, the calculator gets it. All right, calculator's cool. So the volume is going to be pi kilometers. All right. Now we were told to put everything in decimal form, so that would be, of course, 3.14 kilometers. All right, we've memorized that one. It's just so fun to put pi. I just can't resist, even though we're all about the decimals today. All right, so that is it for number 9. All right, for number 10, we are supposed to find the volume and the surface area of this sphere. Well, the volume of a sphere is given by the formula 4/3 pi times the radius cubed. And they gave us the radius, so that makes this 4/3 pi times 21 cubed. Alrighty, so 4/3 pi times 21 to the 3rd power. So that gives us this. So if we needed an exact answer, there it is. But we are being asked for decimals. You know what? I better write it down. Somebody is going to give me an exact answer, and I'm going to need to know what it was. 1, 2, 3, 4. I like it. 1, 2, 3, 4, 8. Okay, so anyway, back down to business. That's 38,792. .39. Got to round up. Units, meters. So these will be cubic meters. All right, so that's it for volume. How about surface area? Surface area is given by the formula 4 pi r squared. All right, so the surface area will be 4 pi. Again, the radius is 21. Okay, so 4 pi 21 squared. All right, 1764 pi. All right, and this will be meters squared. $5,541. I should put it underneath. All right, 5,000. 0.77. Alright, that is it for number 10.